Aim of the experiment: to identify washing soda or baking soda among given samples of chemicals. Theory: washing soda is chemically known as sodium carbonate decahydrate, and baking soda is sodium bicarbonate or sodium hydrogen carbonate. They exist as fine, white crystalline solid powder. When dissolved in water, their aqueous solutions are alkaline in nature and turn red litmus blue. Carbonates and bicarbonates react with dilute acids with a brisk effervescence and produce carbon dioxide gas, which bubbles out vigorously from the reaction mixture. The chemical equations for the reaction of sodium carbonate and sodium bicarbonate with a dilute acid such as hydrochloric acid are shown here. It is evident from the reaction equations that they both follow a more or less similar reaction pattern with an acid, with similar products being formed for the same acid. When the carbon dioxide gas evolved is allowed to bubble through a clear solution of lime water, chemically known as calcium hydroxide solution, the gas turns lime water milky. The reaction between carbon dioxide and lime water is as shown here. The calcium carbonate formed is a white-colored substance that is insoluble in water. This insoluble calcium carbonate is what turns the lime water cloudy or milky. If excess carbon dioxide is further allowed to bubble through the milky lime water, the turbid solution becomes clear again due to the formation of soluble calcium bicarbonate instead of calcium carbonate, which is insoluble. Materials required: an assortment of 4 or 5 test samples consisting of some common laboratory salts. For the purpose of this video, we have taken samples of sodium chloride, ammonium chloride, magnesium sulfate, and sodium carbonate. You may also include sodium bicarbonate among the samples. Red litmus paper, lime water, dilute hydrochloric acid, 5 test tubes, 6 droppers or pipettes, 4 spatulas, a test tube stand, a simple apparatus consisting of a wide-mouth 100 ml Erlenmeyer flask fitted with a 2-hole rubber cork, a thistle funnel and a delivery tube bent at right angles in 2 places are fitted into the 2 holes of the cork as shown here. You may also use a 25 by 150 mm wide-mouth test tube in place of the Erlenmeyer flask. A glass rod. Procedure: take about half a spatula each of the 4 given salt samples separately in 4 test tubes. Label the test tubes as A, B, C, and D. Add about 5 ml of distilled water in each tube. Gently shake the contents of the tubes. Place a drop of each solution on separate red litmus paper strips, using separate droppers. Note the change in color of the litmus papers, if any, in each case. Record your observations. Next, add a few ml of dilute hydrochloric acid to each test tube. Record which tube produced an effervescent reaction, releasing gas bubbles. Perform the lime water test with the sample that produced an effervescent reaction. To do this test, take 2 to 4 spatulas full of the sample in a 100 ml Erlenmeyer flask or a large size test tube. Cover the mouth of the flask or the tube using the rubber cork pre-inserted with a thistle funnel and a delivery tube. Immerse the free end of the delivery tube into a test tube containing lime water. Note that the lime water is clear and colorless. Now, add about 20 to 30 ml of dilute hydrochloric acid through the thistle funnel. Make sure that the free end of the thistle funnel is submerged in the acid. Allow the gas evolved to bubble through the lime water in the test tube for a few minutes. Record your observations. Allow even more of the gas to pass through the lime water for an even longer period of time. Add more of the sample and more of the acid in the flask if necessary. Record your observations. Observations. When a drop of each sample solution was added to the red litmus paper strips, sample D alone could be seen to turn the red litmus paper blue. Samples A, B, and C did not change the color of the red litmus paper strips. When several drops of dilute hydrochloric acid were added to each of the samples in the test tubes, it was again observed that sample D alone produced an effervescent reaction with the dilute acid. When the gas evolved by sample D with the acid was allowed to pass through the lime water in the test tube, the gas turned the lime water milky. When more of the gas was bubbled through the milky lime water for several minutes, it was also observed that the lime water became clear and colorless again. Results and discussion. For the purpose of this experiment, 4 different salts were considered. Sample A was sodium chloride, sample B was ammonium chloride, sample C was magnesium sulfate, and sample D was sodium carbonate or sodium bicarbonate. Carbonates and bicarbonate salts are classified as bases. Aqueous solutions of bases are capable of turning red litmus blue, which was seen in the experiment that we have just performed. Metal carbonates and bicarbonates react vigorously with dilute acids to produce copious amounts of carbon dioxide gas. The reaction is also known as brisk effervescence or fizzing. This was also one of the observations made in our experiment when dilute hydrochloric acid was added to sample D. The identity of the gas evolved is confirmed to be carbon dioxide gas by passing it through lime water, chemically known as calcium hydroxide solution. Carbon dioxide gas reacts with calcium hydroxide to produce insoluble calcium carbonate, which precipitates out as white insoluble particles. This is what makes the lime water appear milky after passing carbon dioxide gas into it. However, as more of the gas is bubbled through the lime water, the reaction proceeds further, and the insoluble calcium carbonate now begins to react with the excess carbon dioxide to produce calcium bicarbonate, which, unlike calcium carbonate, is soluble in water. This is the reason why the milky lime water eventually turned clear and colorless again when excess of carbon dioxide gas was bubbled through it. This experiment thus shows that carbonates and bicarbonates can easily be distinguished from other salts by their characteristic brisk effervescent reaction with dilute acids and the resultant production of carbon dioxide gas, which is able to turn lime water milky.